Today, I'm here to explain about this question. Find the absolute extrema of the following function and where they occur. The function is here. So let's get started. So again, this question you have to find the maximum value and minimum value in this domain. So I'm not sure what does the graph look like, but for example, if the graph is like this, you have to find the maximum value and minimum value in the domain between -2 and 4. I mean x value. Yeah. So what you have to do is you don't actually sketch the graph. You don't need to sketch the graph, but you need to know when the graph is shifting from increasing and decreasing. If you know that like this curve, and where exactly and this point, it's called critical point. If you find the critical point and where it increases and decreases, you can actually find the value. So let's get started. So to find the critical value, I mean here, like this value, you have to differentiate this function. Let's have y prime 3x squared negative 6x. Then when y prime equals 0, the graph has the critical point. So let me find when y prime is going to be 0. Let me factor it. Oops. Then actually x equals 0 and 2. So yeah, this graph is a little bit distorted, but oops, sorry. So when x equals 0 and x equals 2, this graph has a critical point. So let me just re-sketch this graph again. So when it equals 0, yeah, I'm not sure yet. And next, again, you want to find the shape of the graph. I mean, when the graph is increases or decreases. So let me have the diagram here. The domain is between -2 and 4, and let me just add critical points here. Then let me write y prime. Again, when x equals 0, y prime equals 0. And let's find if it increases or not. So for example here, when x equals between -2 and 0, let me plug in -2 here. 3 times 4, -6 times -2 is positive. So this means the value of y prime is going to be positive. You know what does it mean? The value of y prime is positive. When the value of y prime is positive, this means the tangent slope is positive. This means the graph is increasing eventually. So the graph is going to be like this or like that. And let's find the value here as well. For example, when you plug in 1 into x here, it's going to be 3 -6, which is negative. So the y prime value over here is negative. And about this one, if you plug in 4 into here, it's going to be 3 times 4, 16, -6 times 4, which is positive. So now somehow you can sketch the graph, kind of, not exactly. Again, the graph has critical point when x equals 0 and 2, and between -2 and 0, the graph is increasing, and between 0 and 2, it's decreasing. And it has a critical point here. Sorry. And then it's increasing again, like this. So actually the graph is going to be like this, but again it's not exact graph, okay? So there are some possibility, like the maximum value would be this one or this one, and then minimum value is going to be this one or this one. So let's find out. Y value, when x equal -2, y value is going to be -8, -3 times 4 plus 4, which is -8, -12 plus 4, which is -16. And when x equals 0, y value is 4. When x equals 2, y value is 8, -3 times 4 plus 4, 8, -12 plus 4, and which is 4. Which is 4. No, which is 0, sorry. And when x equals 4, it's a little bit annoying to calculate, but 4 times 4 times 4, 16, 24, 64, negative 48 plus 4, which is 20. So now you know the maximum value is here when x equals 4. Maximum value is 20 when x equals 4, and minimum value here is -16, and when x equals -2. Actually these maximum and minimum called absolute maximum and absolute minimum. So let me just write it here. Yeah, that's it. So technically what you have to do is to sketch this table. First you have to find the domain of the graph, then next you have to differentiate the function, then you have to find the critical points, then you add these points as well. Then next you have to find, if the graph is increasing or decreasing, and later you're going to find the y value, then which one is positive, which one is maximum, which one is minimum.